All right, I had another question about finding the area underneath the curve, and it's a quadratic equation. One of the things that's tricky about a lot of times we just say, oh, the integral tells you the area under the curve. And that's not entirely true. If the function goes below the x-axis and then back above the x-axis, the integral will tell you the difference between the areas on either side, because areas below the x-axis will cancel out the areas above the x-axis. So we just have to be careful. So what I'm going to do is first just factor this. So I think it factors x minus 2 times x minus 3. And what that tells me is that if x equals 2 or if x equals 3, then the y value is going to equal 0. So just to help visualize, I'm seeing it starting up here at 6, hitting at 2 and 3. That's not very to scale. I'm going to draw that just a little better. So it's going from 6, coming down from 2 and 3, just like that. So the difficulty here is that if I just took the integral, it would actually subtract this negative area right there. So the question asked me about the total area here between 1 and 4. In other words, it wants me to do this, where I put absolute value bars around it. Well, there's no real closed form antiderivative for absolute values, so because it behaves differently at different points. So what you need to do is break it up into different parts. So I know that I can break this up to be the integral from 1 to 2 of the regular function, because it's positive between 1 and 2, plus, so this is all one big line, the integral from 2 to 3 of the opposite of the function. So I can just put a negative in front here, and that'll take care of it, the fact that it was negative there. And then plus the integral from 3 to 4 of the regular function again. So the integral of that is the same in all three of these. So we have x cubed over 3 minus 5x squared over 2 plus 6x, and we're going to evaluate that from 1 to 2. Then we're going to subtract that whole thing. I'm just going to abbreviate. Subtract that whole thing from 2 to 3, and then add that whole thing from 3 to 4. Some of these values are going to show up again and again, and so there you can get clever and try to simplify it as you go along. So if I plug in 2, I get 8 thirds, because 2 cubed is 8, minus 20 halves, 2 squared is 4, times another 5, plus 12, minus, then I'm going to plug in 1 third minus 5 halves, plus 6, and then I'm going to subtract f of 3. So f of 3 is going to be 27 over 3. I'm going to grab this all in brackets. 27 over 3 minus 45 over 2 plus 18 minus f of 2. But I already figured out f of 2. 8 thirds minus 20 halves plus 12. And then plus f of 4. So what is 4 to the third? 4 times 4 times 4. 64 over 3 minus 80 over 2 plus 24. And I already figured out f of 3. 27 over 3 minus 45 over 2 plus 18. So whatever this all ends up being is kind of what our final answer comes out to be. So this last part of the video is not very exciting. I can just really just typing things into the calculator and seeing what happens. I'll just type it all in as one long string of things. and just hope that I don't make any parentheses errors as we go through this. Yeah, and really, since I'm resorting to the calculator anyway, I should have just typed in the original functions as we go. Anyway, so what happened here? Does that look right? That all came out to be 1.83. I'm just going to double check that I didn't make a calculator error. You can always go to your y equals menu and type in your original function. And the nice thing is you can even put the absolute value right in front of it like that. So if you put the absolute value in front of it, then it will take care of that part where it dips below. So here's what I've got inputted. I'm going to just look at the graph of it. Pretty much like what I drew. Come on, there you go. And then you can get your integral by using the calculate menu. So if I hit the calculate menu and then number 7 brings me back to here. And I care about the answer between 1 and 4. So I just hit 1, hit enter, hit 4, hit enter. And it tells me 1.83, just like that. So I must have been right. All right, so thanks for watching. Please ask questions, comment if there's anything confusing. Thanks.